Welcome back to Pre-Calculus. We are here in Unit 9 and Lesson 4. And today's learning target is continuing with 9.b, where we were performing basic operations on two-dimensional vectors. So the first operation we learned about in the last lesson was multiplication by a scalar. So instead of having a vector v, we learned how to calculate something like 2v or negative 3v. Today's video is going to focus on a different set of operations, namely addition and subtraction. So if I have two or more vectors, how do I add them together or subtract them from one another? So graphically speaking, adding vectors places them head to tail. So if you have two different vectors, two different arrows, if you put them head to tail with one another, you will get the sum vector. So for instance, if you drive 7.1 miles northeast and then 3 miles due east, where would you end up? So the first vector represented here is 7.1 miles with the direction to the northeast, and you can see that represented here. It has a length of 7.1 and a directionality northeast. And then you go 3 miles due east. So this would have a length of 3 and a direction straight to the right, straight to the east if you were looking at a map. But now you don't automatically reset at your starting position when you switch from going northeast to going east. So a much more realistic way of representing what actually happened on your drive is first you go the 7.1 miles northeast, and then from there you go 3 miles to the east. So your total distance of travel, your overall displacement, the point where you end up, would be from the starting point to the end of that second leg of your trip. Some people refer to this as an as the crow flies distance. If you didn't have to worry about roads or turns and could just go straight from point A to point B, what would be the most direct path to do that? Well, that would be the sum of the two legs of your drive. So this would be vector A plus vector B. So graphically, if you want to add two vectors together, you place them head to tail with one another. Computationally speaking, if we have two vectors, u and v, each of which represented with some x and y coordinates, so u sub x, u sub y, vector v has terminal point v sub x, v sub y, then if you want to add them together, you add them by coordinates. So you would add the x coordinates together to get the x coordinate of the sum. You would add the y coordinates together to get the y coordinate of the sum. So let's look at some examples here. Vectors a, b, c, and d are defined as follows. A is 3, 2, b is 1, 4, and c is negative 5, 2. We want to calculate and graph each of the following. So let's start with the calculations. Vector a plus b. A is given by 3, 2, and b is given by 1, 4. So if we want to find the sum vector, we simply add it coordinate-wise. So the x coordinates, 3 and 1, get added together, and the y coordinates, 2 and 4, get added together. And that gives me a sum vector of 4, 6. So now let's think about how we would graph this. Vector A is 3, 2. So I would go to the right by 3 and up 2. There's the terminal point, and there is vector A. Now vector B is given by 1, 4. So instead of going back to the origin and going to the right 1 and up 4, I'm going to start off where my last vector ended. So I'm going to start here at this point 3, 2, and from there go to the right by 1 and up 1, 2, 3, 4, and put vector B tail to head with vector A. And where do I end up? I end up right there. That would be my final terminal point, which has coordinates of 4, 6. Look familiar? Yes. A vector that started at the origin and then went straight to point 4, 6 would have the same effect as the sum of those two vectors A and B. Let's look at another example. This time we want to do vector B plus vector C. So vector B has terminal point 1, 4. Vector C has terminal point -5, 2. So if we add those together, we're going to be adding the x-coordinates 1 plus -5 and the y-coordinates 4 plus 2. And then we end up with -4, 6. So on the graph, if we place vectors B and C head to tail, we should end up at the point -4, 6. So let's see what this looks like visually. Starting off with vector B, terminal point 1, 4. So I start at the origin, end at the point 1, 4. There is vector. Let's draw that a little more neatly. There is vector B. And then we're adding to that vector C. Vector C has coordinates -5, 2. So from my starting point, I would be going to the left 5 and down by 2. So instead of starting from the origin, I'm going to start where my last graph ended. So starting from this point here, going 1, 2, 3, 4, 5 units to the left and 2 units up, drawing vector C tail to head with vector B, then that would be my terminal point, which, unsurprisingly, has coordinates of -4, 6. So if I start in standard position at the origin and go straight to the point -4, 6, that is the same as the sum of vectors B and C. One more example, we have A plus C. So calculation-wise, we are adding 3, 2 and -5, 2. So if you add the x-coordinates, 3 plus -5, that will get us to -2. And adding the y-coordinates, 2 plus 2, gives us 4. So vector A involves going 3 units to the right and 2 units up. So I will start my first vector at the origin, go 3 units to the right and 2 units up, and draw in vector A. And then vector C involves going 5 units left and 2 units up. So I'm going to start where my last vector ended, and from there go 1, 2, 3, 4, 5 units to the left and 1, 2 units up. So vector C would end up right there. So the sum of the two, from the start of the first one to the end of the second one, puts us right there, which has the coordinates 2, 4, or rather -2, 4, as we predicted. So that is how you would add vectors. Graphically speaking, you put them tail to head to tail, one after the other. Computationally speaking, you just add up the x-coordinates and add up the y-coordinates. Subtracting vectors is not much more complicated. Subtraction, you could think of it as adding a negative. So graphically speaking, subtracting a vector is the same as adding or placing head to tail the negative vector. So imagine here I'm given vector A and vector B. You can see those on the graphs. And you want to imagine what is vector A minus B going to look like. So the first thing you'd want to do is figure out, okay, I know what B is. I'm shown it right here. Well, then what is negative B? Well, negative B is going to have the same length and just go in the opposite direction. So if B is going to the bottom right, negative B is going to go to the top left in equal distance. So that would be negative B. And then if you want to do A minus B, you could think of that as being equivalent to A plus negative B. So you would just start with vector A that you were given right here, the same as it was at the start, and then add to that, place it tail to head with the vector negative b, which is what you see right there. That would be vector negative b. And then the difference of these two would be from the start of the first one to the end of the last one. This right here would be the length and directionality of vector a minus b. So computationally speaking, you would, or graphically speaking, subtraction is the same as adding a negative. Computationally, if you are subtracting two vectors, then you just subtract the coordinates. So this is very similar to addition. If you are adding the vectors, you would add the x coordinates. Subtraction, vector u minus v, then you would subtract the x coordinates of the two, and you would subtract the y coordinates of the two. So let's look at some examples here. We are given a few different vectors, and we want to calculate and graph each of the following. So the first one is vector a minus b. So we're given that vector a is negative 3, 2, and we're subtracting from that vector b, which is 1, 4. So we just want to subtract the x coordinates and then subtract the y coordinates. So x coordinates, it would be negative 3 minus 1. Y coordinates would be 2 minus 4. Negative 3 minus 1 is negative 4, and 2 minus 4 is negative 2. So we would expect this difference vector to, in standard position, start at the origin and end at negative 4, negative 2. So this is what we would expect our final resultant vector to be. Let's look at vectors a and b individually and make sure that that all lines up. So vector a is at 3, 2. So going to the left 3 and up 2. That is vector A. Vector B is given by 1, 4. So to the right 1 and up 4. So if we want to subtract vector b, the first thing I would do would be to find the vector negative b. So instead of going to the right 1 and up 4, negative b, well, I'll go use a slightly darker color blue here, would go to the left 1 and down 4. So this would be vector negative b. And if I take vector b and add it on to vector a, going to the left 1 and down 4, sure enough, we end up at the difference vector a minus b, which is the same as what we calculated. Let's do another example. This time let's do b minus c. So mathematically, we can subtract 1, that's positive 1, positive 1, 4, minus negative 5, 2. So subtracting the x coordinates, and here just be careful when you're subtracting negatives. This is 1 minus negative 5, and for the y coordinates 4 minus 2, 4 minus 2. That gives us 1 plus 5, or 6, and 2. So we would expect vector b minus c to start at the origin and end up at 6, 2. So that is what we would expect for the resultant vector right here. Graphically speaking, vector b is given by 1, 4. So starting at the origin, vector b would go to the right by 1 and up by 4. Vector c is given by negative 5, 2. So going to the left 5 and up 2, that would be vector c. So if I want to subtract c, or find vector negative c, then that would be going to the right by 5 and down by 2. So in standard position, this would be vector negative c. And if instead of drawing it in standard position, I draw it added on to vector b minus c, or vector b plus vector negative c, going to the right by 5 and down 2 more from there, sure enough, we end up at 6, 2. So I'll just highlight this one more time to help you visualize. This is vector b. We're adding on to that vector negative c, and that gives us the total displacement vector b minus c. And we have one final example here. This time we want to do c minus a. This time let's graph it first. So vector c is given by negative 5, 2. So starting from the origin, going left by 5 and up by 2, that would be your visual for vector c. And we want to subtract from that vector a. Vector a is given by negative 3, 2. So to the left 3, up 2, that is vector a. So if I want vector negative a, then it would be the reverse of that. Instead of negative 3, positive 2, that means that negative a is positive 3, negative 2. So starting from the origin, going positive 3 and negative 2, this is vector negative a. And if I take vector negative a and tack it on top of vector c, so starting at the end of vector c here and going negative 3, or positive 3 units to the right and 2 units down, I end up right there. So if I trace out the path of vector c and then vector negative a, I end up at this point here, negative 2, 0. So the difference between those two vectors would be the difference vector right there in black, 2 units straight to the left. And we can also calculate that out. Vector c is given by negative 5, 2. And vector a is given by negative 3, 2. So if we subtract the x-coordinates, negative 5 minus negative 3, and we subtract the y-coordinates, 2 minus 2, we are ending up with negative 5 plus 3, which is negative 2, and 2 minus 2, which is 0. So sure enough, that is where we end up. So now you know how to multiply a vector by a scalar, and you also know how to add and subtract vectors, all given in standard form.